Cool, thanks for the intro, Ian. So I'm going to give the quickest introduction to what CNCF is as possible in 15 minutes. That's definitely not enough time to dive into Kubernetes, but I'm assuming most people in the room know what Kubernetes is. Is that, raise your hands? Okay, it's about half. That's pretty good. Who knows what CNCF is? That's usually like no one. Oh yeah, see, it's usually less than the people that know what Kubernetes is. But to give you like a brief history, CNCF is part of the Linux Foundation. I won't talk about that. CNCF was founded in late 2015, and essentially it was built to be a foundation, an open source foundation for Kubernetes, but not only just for Kubernetes, because once you get into orchestrating containers, there is a lot of other kind of ancillary open source software that you need. Essentially, you need to know how to do monitoring at that scale, how to do logging, tracing, and so on. So a lot of things have to kind of be reinvented for Google grade orchestration for containers. So we started very simply with just Kubernetes as our first project, and with just 22 member companies. And so that was a little under 2 years ago. Today, we have 141 members. In less than 2 years, we have 6x growth, which has just been crazy since I've been involved with the foundation since the beginning, to kind of see how quickly Kubernetes has grown. I was just at DockerCon in Copenhagen last week, and Docker, who was kind of let's say like an initial holdout of adopting Kubernetes wholesale, finally announced that they're going to be supporting Kubernetes within the Docker Community Edition and Enterprise Edition platforms. So good news around. And if you notice, one thing that's interesting with this is in the terms of the membership, we have basically all relevant major cloud providers, including Amazon, bought in. So to me, that's kind of unique for essentially the cloud native space. Kubernetes has grown a lot in terms of the last 2 years, even though the board kind of was pissed off at me in terms of the directions I was setting the foundation. But if you notice the trend line, since Kubernetes joined CNCF, it's been nothing but up and to the right. So that's what I always try to tell my board. It's one of the highest velocity projects out there too. So it's being, in terms of the actual amount of commits, pull requests open, and so on in the last year, it's insane. It's a lot to deal with. Actually, we run into issues where it's hard to actually use GitHub to manage the amount of inbound contributions. So we're creating some tools on top of GitHub to deal with the crazy amount of inbound contributions. So a little back to CNCF. So like I mentioned, we have we're seeded with Kubernetes as our first project. However, we have 11 other projects, and we kind of continue to grow. And they are in different spaces. So some of them, like I mentioned, are in monitoring of kind of monitoring our architecture. Others are around common networking APIs to be used across the container space. There's something called service meshes. We have a couple service mesh projects, which essentially are ways to centralize how you manage and monitor your services. We have the 2 container runtime projects that are actually relevant in this space. So I don't know how many of you heard of the container wars a long time ago, Docker versus CoreOS, Rocket. We brought them all into CNCF, so no one really talks about that anymore. So they're all neutrally governed projects. We have some distributed tracing technology. So we have a kind of mix of stuff that you're meant to basically pick and choose what's relevant to you. So we don't force integration of our projects. Each of these projects are actually independently run. So we don't force them to adhere to something like, Eclipse has the Eclipse way, Apache has the Apache way. The CNCF way really doesn't exist. It's more of, you just need to independently define your governance for your project, how you do releases, how you elect committers, and so on, and just publish that, and just have a fair way to elect committers, and that's it. And it's kind of interesting that even though we don't force like integration or cohesion, a lot of these projects actually do work together fairly well. It just naturally happens. As I soon learned when I started working with CNCF, this space is actually super complicated because there's lots of different solutions out there. So we put together this crazy little diagram that shows you essentially all the relevant kind of technology in cloud native. So from anywhere from storage to security to platform CI/CD, what open source options are out there. And of course, we obviously highlight the projects that are part of CNCF as essentially what we call like kind of blessed or recommended solutions, but we have enough hindsight to basically say, we know there's other good solutions out there, but feel free to pick and choose what you need, essentially, from cloud native. And I think part of this goes to the notion within CNCF is that we think there are many pathways to cloud native. Like there's not just one way to get there. There's even different orchestrators out there. There's different ways to monitor your containers and so on. So this is kind of viewed as like a map, and there's many kind of ways to get there to cloud native. So I could kind of go through the history of cloud native. This is kind of entertaining. So containers actually have been around for a while, but if you kind of remember how people wrote applications a long time ago, you used to just like buy servers from Sun, right? You just or buy some hardware from kind of a vendor, and the building block of your application, you built it to target a server, generally, right? As things went on, virtual machines came around, and so this was good. You could actually pack more stuff into one machine, and eventually the kind of building block for your application targeted virtual machines. Eventually, AWS came around and really popularized the notion of essentially infrastructure as a service. Your building block for your application still ran on a virtual machine. You still targeted a VM, but you kind of had this great notion of you essentially get the rent server time. So you basically converted your CapEx cost to OpEx. So cool innovation. Heroku came around in 2009. Eventually popularized the notion of build packs, which are essentially kind of fancy ways to kind of describe your applications a little bit lighter weight than a VM, but it made it very easy to deploy applications kind of using Git-related commands. So we know this as platform as a service, and there's lots of different options there now, but Heroku is really the first one that really popularized this. 2010, OpenStack came around trying to do an OpenStack or open source version of essentially AWS and IaaS. They've had some success, but essentially the thing to note here is it brought together a bunch of different vendors trying to do this in an open source fashion. And still the application building block was a virtual machine. Cloud Foundry eventually came around and tried to do like an open source Heroku in the most simplest way I could describe it. But some of the new things here was building block was still somewhat a virtual machine, but they started to add support for containers. But this was done in the open. 2013, Docker kind of comes out of nowhere and popularizes containers. Essentially really brings containers to the masses, in my opinion. And so in 2015, we essentially formed the CNCF to bring together a different set of technologies to promote the notion of cloud native computing. And I didn't really define cloud native when I started, but essentially all cloud native means is you write services that run in containers that are orchestrated by some central system. That's it. That's all we refer to when we say cloud native. And so the timing was right. Docker essentially popularized containers. People were starting to use containers as kind of constructs, and hey, I just need to package my stuff and make sure CI and CD works, and I can replicate environments. Eventually, people really started to run services in production using orchestrators. So we wanted to build a home for open source technology that helped promoted this notion of computing. So if you kind of look at this rough history diagram, I think there's been some interesting kind of changes that could be summarized over time. So for core building blocks for your applications, we've essentially moved from just hardcore, you're just buying servers and running stuff on physical servers, to VMs, to kind of build pack constructs on passes, to actual containers. Some people may argue we're even going a little bit further into just functions, which is like serverless land. But to me, serverless is just another form is another programming model that's powered by cloud native. From isolation units, we went from heavy physical servers, VMs, to lighter weight containers. Mutability, from essentially treating each of your independent servers as pets. We went to the hey, servers come and go, services come and go, and so on. And I think the most important thing for a lot of people in this room, especially involved in Eclipse IoT, is we went from closed source single vendor ecosystems to open source cross vendor ecosystem, and this is a trend that's been happening throughout the industry. So that's kind of a brief history of cloud native and CNCF. Blah blah blah. Why projects join CNCF? It's essentially like we're like the Eclipse or Apache Foundation, but targeted on cloud native technology. That's it. So all projects have to essentially be related to running containers, orchestrators, or some aspect of that, essentially. Blah blah blah. I'm not going to talk about why you host projects at CNCF. So in terms of the actual governance, Ian was like, explain a little bit how CNCF works. We have a governance structure that's similar to any open source foundation, but we kind of have, we call this the three-ring circus. So we have like a governing board, which is like your board of directors. They do the business decisions, they control the budget. We have a technical committee, technical board. They decide which projects come in or not into CNCF. And there's an end user board who essentially represents end users of the technology. And they get to elect someone on the technical board. So we kind of have this business board who just decides budgets, technical board, decides what projects go in technical vision, and end user board has influence on what the technical folks do. And they're kind of all deliberately firewalled off kind of from each other. So kind of a unique structure, but that's kind of how we're doing. We wanted to make sure that end users had a voice within our foundation that was separate from the vendor community. In terms of how you get involved with CNCF, each project, since their governance is unique and independently created, they have different ways of getting involved. So the most popular way to get involved, at least with our biggest project, is Kubernetes. Is essentially based on SIGs, so special interest groups. So if you cared about storage, you would go join the storage SIG. If you cared about networking, you'd go there, big data, and so on. And within these SIGs, they actually get to decide which features ship as part of Kubernetes. So we've kind of decentralized the governance of the project into little SIGs, and they got to decide what actually ships as part of the project. So we don't necessarily have an IoT-focused special interest group yet, but that's something potentially that may be created down the line. I think initially we were so focused on the plumbing of making sure this stuff works. Now we're going to move on and kind of tackle some higher constructs. CNCF itself is, we have what we call foundation-wide working groups. So if there's specific areas that span all of our projects, you would essentially join a working group in CNCF. And so we currently have 4 right now. One of them, we have 4 working groups. They span different areas. Right now we have storage, networking, CI, or cross-cloud CI, and serverless. Essentially, how do you build serverless technology using cloud-native stuff? So, and they're also doing some standardization and specs there. Recent news, the other thing that we're kind of working on is we've had a lot of success in people taking Kubernetes and essentially making it their default orchestrator. One concern we have is what happens if people start forking or changing things in a way where if you deploy an application on one cloud and move it to another, things may break. So we came up with a certification and program and new trademark that basically will help solve this problem. And I will just leave it up for questions. We have a big conference coming up in Austin, so the Eclipse Foundation will be there. They'll have a booth, but if you're kind of interested in this space and want to get involved, I highly recommend attending. So I'll leave it up to questions. So I'm here to answer any questions around CNCF, Kubernetes, how to get involved. So, sure.
So what would be potential issues that you would want to discuss in an IoT
Sure. There's a couple ideas or a couple thoughts that people are working on. One is getting container run times to be as lightweight as possible, so they could run on devices essentially. So as there's different classes of devices, and so how do we strip things down to make things run more efficiently in that matter? And so there's a lot of companies that are attempting to starting to do this. ARM, for example, has a lot of interest in this because they want to make sure this stuff works really well on their specific devices. But yeah, exactly. So the Kubernetes aspect is Kubernetes was designed to basically manage services running containers in ginormous data centers, right? A lot of those concepts are applicable to essentially managing, instead of those containers running in big data centers, they're going to be running on a ton of devices, right? Essentially, maybe those devices report to a mini cloud or edge type thing, right? And you have to manage that. So Kubernetes was not designed to do that, but those concepts map easily, and there's a lot of work going on to figure out how to essentially make that easy. Essentially, if you have a lot of these.
Does that mean having devices as nodes of the Kubernetes cluster?
Yeah, exactly. So, and edge, and multiple edges. So essentially there's some work going around what we call federation in Kubernetes land. So we have all these edge things would be essentially federated, treated as just a large Kubernetes cluster, essentially. So we have some initial work in that area. In 2018, you're going to see a lot more uptick in that.
Other questions? Yeah, I mean, the Kubernetes thing is interesting because of the resource constraints and, there's a lot of single points of failure out in the field versus having replicable services in the cloud. But I think it does map, and, there are a lot of use cases where it would work, and we've certainly been interested in seeing how you could either put Kubernetes itself or have a second application that is a Kubernetes little brother that adheres to the APIs and how Kubernetes works, but is more conformal with the use case. So, I mean, from a Red Hat perspective, we're definitely interested.
Yeah, there's a lot of, as you know, there's been a lot of work in like modularizing the Kubernetes code base to make it a little bit more amenable to those things. So it'll be a big goal in 2018 in making this stuff. Basically, there's a convergence of people wanting it to manage, essentially devices, and there's other folks that essentially want to build edge computing, which essentially is just like mini data centers, essentially. So.
Do you know any kinds of maybe Amazon Web Services to offer a cross Kubernetes platform?
So, of all the cloud providers, we have all the top cloud providers but Amazon offering a managed Kubernetes service. I think with the Amazon conference coming up in November, there will be some announcements that make it easier to run Kubernetes on AWS. I know definitely they're going to improve networking related aspects of AWS to make it easier to run Kubernetes on, and there's rumors of some other things. I think eventually they will offer a managed Kubernetes service. All their other competitors do. It's going to happen.
One more question? Two questions?
Yeah, no worries.
All right, well, thank you.
Yeah, no worries. If not, just email me, so I'm always around.